Magic 8 Ball, will they learn this difficult lesson? It is certain. Let's go. This lesson will be very difficult today. Are you up for the challenge? All right. So, what did we learn about yesterday, right? We had this idea of domain and range for these graphs, and then hopefully that we remember that domain, what is domain, right? What is range? Domain, in your own words, all possible x values left to right. Range, low to high, all possible y values. Here we had the interval forms that, remember, if you had the parentheses, they were open circles. If they had the brackets or the inequality symbols with the equal sign, they were closed circles. And you could have something that's half open and half closed, right? So what's the game plan today? Here, your learning intention is, how can we use, holy moly, what is that word over there? It is time, everybody. We have infinity, right? So how do we use the idea of infinity to describe the domain and the range of certain graphs, right? So this concept will not be easy at first, okay? But we got this. What I'd like you to do is pause the video and try the first question on your own, right? This is just a review from yesterday. For the graph below, state the domain and range, put it in inequality form, and put it in interval form, okay? Pause the video, try this by yourself. Try this by yourself. Okay, so let's imagine that you tried it by yourself. Let's take a look. Domain, how far left, how far right. So let me move these papers out of the way. Let's do this. So domain, how far left, how far right. So let's take a look. Which point is most left? It is over here. And which point is farthest right? It is this point over here. So then what do? Let's show this as an x comma y, right? So what is the x value of this point? It looks like it's -9. And what is the y value of this point? It is 6. What is the x value of this point? It is 4. What is the y value of this point? It is 2, right? So domain is how far left to how far right. So what we do is we say x, this has to be a less than symbol with no equal sign, -9 to 4 equal sign. Oh, let me move this here. Right? What about an interval form? It should be -9, comma, 4 bracket. Okay, for range. Range is how far low, how far high. What is the lowest point on this graph? It is over here. And what is the highest point on the graph? It is over there. So let's label this as a point. My x point is -6. My y point is -1. My x point is 1. And my y value is 9. Right? So then notice that, you see, for domain, we went from -9 to +4. Our range is from -1, right, to +9. So it is -1 to +9. And then these should be brackets. I'm sorry, not brackets, but the equal sign symbol, because these circles are closed. Someone asked a really good question. He said, "Mister, how do you know that these circles are all closed?" Here, this graph shows an infinite amount of closed circles from all the way from the left to right. The only open circle is this circle here. Okay? The range will then have to be bracket -1, comma 9 bracket. Right? All right, let's do this. If you put an x here, that was my fault from yesterday. Because remember, when you do domain, you do left to right. When you do range, you're going low to high, but you're talking about the y values. So in yesterday's video, I made a little mistake. I put an x here, but it should not be an x. It should be a y. So that's okay. We learn from our mistakes. Now let's go through the main part of the lesson. What is the game plan today, right? We need to examine graphs that go all the way towards the infinities, right? So if you have this graph over here, notice that this arrow is saying that the pattern continues like this. The pattern continues like that. It's going all the way to the right. It's going all the way to the left. It's going all the way up. So notice we have to talk about this idea of infinity to get a better understanding of how to show the domain and range for these graphs. So let's take a look over here. We'll take a minute to examine these graphs, right? What do you notice? What do you wonder, right? So really take 1 minute, just pause the video for 1 minute. It really takes something really nice. What are some of the things you notice, and what are some of the things that you wonder, right? What do you notice? What do you wonder? Right? What do you notice? What do you wonder? Okay. Well, here, these arrows keep going on, right? These arrows imply the same pattern. You wonder, what is something that you could wonder? Can I have a positive infinity? Can I have a negative infinity? Right? So how can I use these positive and negative infinities? So we have to have a short 2-minute lesson, and it'll be very short. But what is this idea of infinity? What does it represent? Right? So let's take a look over here. If I have the idea of infinity, it implies that if this is 0, this is 1, this is 2, this is 3, infinity just keeps going. It just keeps going to the right, right? This is positive infinity. This is -1, -2, -3. But this negative infinity implies what? I keep going to the left, right? And the very, very big question that I wonder, Magic 8 Ball, will they get this question right? Is infinity a number? Let's see. What is infinity? Does the Magic 8 Ball know? Is infinity a number? It says you may rely on it. And this is absolutely wrong, Magic 8 Ball. You are absolutely wrong. Infinity, and we'll write it over here, and maybe we should write the notes for it. Infinity is not a real number. It's an idea. It's an idea. So infinity is not a number. It is an idea. The idea of infinity means it is some value that just keeps increasing to the right side for positive infinity. Negative infinity is some number that just keeps decreasing on the left side, right? So infinity is not a real number. So we have to kind of like talk about it a little bit. Let's examine this first graph over here and notice, what do you think we're going to do? Just like we've been doing before, we've been finding the domain and range for each of these graphs. But now this graph is a little bit tricky, because if I say domain, let's review this again. What is domain? Domain is how far left, how far right. Well, let's see. How far left does the graph go? What is the leftmost part of my graph, right? What is the leftmost part of my graph? It's right here. It's right here. And notice, what is this point? It is 3, 0, right? This is my x and this is my y. So if I were to talk about the domain, right, in interval form, because I think it's just a little bit easier, This is a closed circle, right? So what should I do? I put a bracket, I put a 3. If this is some x over here and this has to be like this, 3 is on the left side. So I think this part is okay, right? 3 is on the left side. But then the next question is, 3 is how far left? But how far right does the graph go? How far right does the graph go? So if I'm looking at this graph, and this arrow implies that the pattern just continues and continues and continues, how far right does the graph go? Well, I could just keep extending this towards infinity. I could keep extending this towards infinity. So then how do you think I should do it? Right? How do you think I should do it? Well, first I have to put something like this. Then I have to do something like this. But then the big question for infinity, how should I show it? Should I show it with parentheses or should I show it with brackets? Right? You see, when you show something with parentheses, like this value over here, you remember when we had this point? You see how can x be -9? Can y be +6 over here, right? X cannot be -9 because you don't have it, right? Because it's an open circle. And infinity will imply that same idea that you cannot grab onto it. So then anytime we use the idea of infinity or negative infinity, we must use parentheses, okay? And I'll do a better job of explaining it in person, but anytime you use infinity, you must use parentheses, right? And then here, you should also use the less than or the greater than, not the less than or equal to or greater than or equal to. You do not use these symbols to describe infinity. Okay? Let's take a look. What about for range? Right? Try this one on your own. Let's see how clever you are. Pause the video. Pause the video. For range, how can I describe the range of this graph? Remember, range is low to high. What's the lowest point of this graph? How high does the graph go? Well, let's see. Pause the video. Okay, so if you pause the video and tried it by yourself, let's see. So notice the lowest point is this point here, and what's the y value? It's 0. So notice we start at 0 here, right? So then maybe if I have some y over here, less than or equal to, 0's on this left side. But then the question is, well, how high does the graph go? Well, when we were looking at domain, right, you see how we were looking at the infinity? We were going like this. And you see it went 3, 4, 5, 6. It kept going to positive infinity for the x. Well, let's look at the y. How high is this graph going? Well, it's going to 1, to 2, to 3, to 4, to 5, to 6, to 7. And notice this pattern keeps going more and more and more, and it just keeps getting higher and higher and higher. So then what we could do is we say that it goes from 0 all the way to infinity. It goes from 0 to infinity because this graph keeps going up. And then how should we close it here? With the parentheses. How should I write it here? Like this. Okay? I said this lesson will be difficult, but the magic 8 ball said what? You would get this. You would get this. So let's continue. Right? So we did it for the first one, and notice that you had this picture and it kind of went to the right. Now let's look at this picture over here. What do you notice? It's something here and it's going like that. Pause the video, try this by yourself. Can you describe the domain and range for this one? And this is where it gets tricky. It gets very tricky. So let's take a look. Domain is, let's remember, it is how far left, how far right. So notice we have to start on the left side. The same thing here. We didn't start over here on the right side, we started on the left side. So if I were to start on the left side, notice, well, where is the leftmost point of this graph? Oh, doesn't it just keep going and going and going? It keeps going and going and going. It's starting somewhere in this negative infinity. It starts because every time you do domain, it's always left to right. So where are you starting? You're starting towards this negative infinity side. So the way you have to do it is you say negative infinity. Right? You're starting towards this negative infinity, and where's the rightmost side? Over here. It's at 7, 0, right? So this is my x and this is my y. So then it has to end at 7 bracket. All right. Okay, you see how it was a little tricky, right? Now for this one, the way you would describe the domain, you're used to maybe, if you wrote this, negative infinity less than, let's see, x less than 7, then you're kind of close, but this is a little bit wrong. Because the way you would do it is x is less than or equal to 7. Because what this inequality is saying is you have every x number less than 7. Okay? Now, looking back at this is wrong. What do you think I should put over here? This has to be x is greater than or equal to 3. Okay? So then I made a mistake over here with the inequality symbol. It should look something like this. So the idea was for you to really learn this well. I made a mistake on how to teach this one. So let's see if I could catch myself for the next one. Here for the range, how can I do the range? Notice that the range is increasing from 0 to infinity. From 0 to infinity. So how should the range be? It should be from 0 to infinity. And then the y value should be y is greater than or equal to 0. Because what this is saying is you have every y value that's greater than 0. You have y is 0, y is 1, y is 2, y is 3, y is 4. Okay. Let's see if you can do the next page on your own. Let's see if you could do the next page on your own. This gets very tricky. This gets very tricky. Okay? So try this on your own, and then we'll get together in class to recap.